What if you could run a fully multimodal AI agent, one that can actually see images completely on your local machine? No API keys, no cloud bill, no data leaving your device. That's exactly what we are building today. We are going to build a multi agent setup using Google's brand new Gemma 4 model, running it locally through Ollama and wiring it up with Google's agent development kit. And the demo we are building is a screenshot explainer agent. You drop in any screenshot, could be an UI, an error message, a piece of code, and the agent will visually analyze it and tell you exactly what's going on and what to do next. Fully local, fully private. Before we jump into the code, I want to take a few minutes at the whiteboard, explain Gemma 4, the different variants available, and why I picked the one I did, and how Ollama and vLLM differ, because that context will make the code sense before we get into it. Alright, so let's talk about Gemma 4. So Gemma is a Google DeepMind's family of open weight models. So when I say open weight, I mean the actual model file are yours to download and run, completely free and commercial use allowed. Now Gemma 4 is special because it built from the same research that powers Gemini 3, Google's most advanced proprietary model. So you are getting frontier level intelligence, but in a model you can run on your own hardware. It's multimodal, meaning you can give text, image, and audio as input, and also it supports 140 plus languages, and also it has native function calling built in, so that is why it supports my ADK agent. Now let me explain the four types of model. One is E2B, E4B, 26B, A4B, and 31B dense. This E2B and E4B are used for edge devices so that the parameters are less. So this E2B has approximately 2 billion parameters, and this E4B, as the name suggests, it has 4 billion parameters, and these two are both suited for both edge devices like mobile phones, Raspberry Pi, laptops, etc. And this is a 26 billion parameter model, and this one is a 31 billion dells model for high quality. So in this 26 billion model, so what it means is used for fast inference. So as it says 4 billion active, it's like when the model is loaded with 26 billion, but when you are running inference, actually only 4 billion parameters are active, so that it gives us fast inference, and also the quality of the inference output will be equal to 26 billion. So that is the main use of this model. And also this 31 billion dense parameter model is a high quality model. It is used to run, you need high GPUs in order to run this. If you have more GPUs, more VRAM, about 30 or 40 GBs of VRAM in your laptop, you can easily run this. But I have in my laptop I have only 4 GB of VRAM, so I am going to show you how to run this 2 billion parameter model, and to your surprise, it also works very good compared to other open source model. This Gemma 4 is really worth it. You need to try this actually. And also you can run this 32 billion model in the Google Cloud Run or GKE also. If you don't have GPUs in your local system and you need to run the open source model, you can run it in Cloud Run or Google Kubernetes engine also. Yeah, now let's go to the next part. Okay, now in order to run the Gemma 4 model, we need a inference runtime. So for that I will explain what is Ollama and vLLM. What both these have in common is they both are inference runtime servers, so which we can easily host it in our local system or cloud to get the API endpoints to run our model. So it basically gives us API endpoints for our Gemma 4 or whatever open source model you run. Now let me tell the difference between Ollama and vLLM. Ollama is a local first inference runtime, so it's basically used for testing, all those purposes. If you are using it for a personal use, Ollama is the best. And this vLLM is a production inference server. Let's say if you want to host your model and you wanted to make it ready for production, then vLLM is the best choice for you. Now let me tell the key differences between them. So this Ollama is one command install, runs on CPU or GPU, and also you can easily download the model using a single command. And also the APIs are OpenAI compatible API, and it is great for developers and demos. So as I said, if you are developer and if you want to test it or you want to use it for your personal, you can go with Ollama. It's best for that. It's easy to set up. So now let me tell about vLLM. So vLLM is a production inference server. It is used to host your model for production ready tools or production ready systems. If you want more people to use your system or models, then you can go with vLLM to host your models. So first feature is max throughput at scale. So at scale in the sense means when you want multiple people to use your model at the same time, then it gives us maximum throughput compared to Ollama. It's best suited for only a single user, but it's not suited for multiple user. vLLM is the best for scaling your model. Next one is paged attention memory. So now in order to explain this concept, I will go to the whiteboard. You might have heard about attention mechanism. So it's a common concept in LLM. So LLM came into existence because of attention, I would say, because this is the key feature and core concept in LLM which makes it so powerful till date. Yeah, so now let me tell you what is paged attention concept. So before going to paged attention, let me tell what is attention. So attention is basically generating key value pairs for a query which you give. So I don't want to get more deep into the mathematical concept, so I will just give you an overview of it. So key value pair in the sense, so what this attention does is whenever you give a prompt, it will try to generate a key value pair. Let's say I am giving who as a prompt. So what this key value pair does is it will generate which is the more appropriate word which will come next to who. So say there are multiple words R, Y, U. So these three words are there. Now what this attention does is it gives a probability on these three words, like how much probability this R will come next to who. We can say it's about 90% probability, because most likely who R only must come to who. And also Y, let's say it says 5%, and this one is also 5%, because the Y and U almost there is no possibility of coming next to who, so that we have given lesser probability for this. So this is what attention mechanism, it generates a key value pair. So these are the keys, these R, Y, U, what are the possibilities are there are the keys, and V are the values. These are the values, I mean how much probability it has. And this one is the query, this who is the query. So this attention is it basically generates a matrix of key value pair, query, key and value. Based on this it will generate a matrix. This is what attention on a high level basis. I'm not getting depth into the mathematics actually. So now, so why I told you this concept is so while running LLM we need to allocate memory. Let's say you are giving a prompt as who, and you need to generate as who are you. Let's take Gemma for itself as an example. Now what we are doing is we are giving who as a prompt to Gemma 4. So what our end goal? Our end goal is it must generate and give us who are you. We need this as output from Gemma. So I'm just going with a simple example. So yeah, so we are just giving who as an input to the Gemma 4. So what it will do? First it will convert this word into tokens. LLM doesn't understand these characters actually. So what it will do? It needs to convert into mathematical form. So this who is converted into tokens. That is a mathematical representation of who. Let's say there are some numbers in it, and after this tokens are generated, then these tokens will be converted into embeddings. Embeddings is a multi-dimensional vector. It's also a number, so it's a multi-dimensional vector which represents who. And after this is converted, then it goes into the attention mechanism. So what this attention does, it generates key value pair for the who word, and then after generating key value pair, it identifies that the next word is from the probability here, it identifies the next word is R, so that now we got the word who are. And also LLM will generate the words token by token only. So if you give who, it generate only one word, that is r. Now the r is generated, we get two words. Now what it will do, again this who r is again fed to LLM. Again it repeats the following steps which I told, which is the tokens generation for who r, token generation, embeddings, and afterwards again attention mechanism for both who and r, that is key value pair for both who as well as r. So you can see this, we have already generated the key value pair for who in the previous step itself, but we are again generating it in this step also. So it is a redundant work, right? So in order to cut this redundant work, there is a concept called KV cache, that is basically key value cache. So what we will do, we will store the key value pair matrix in a cache, so that we don't need to generate each words again and again repeated redundantly. So let's say if the token size in the prompt size is large, means each and every time it will generate the key value pair for everything. So who are you, I am Hari, so like that it will generate for each and every word, it will generate key value pair n number of times. Each time a prompt is generated, from the first it will generate key value pair. So in order to reduce the redundancy, they introduced a concept called KV cache. So what we will do is, we will store that key value pairs in the memory. So this is what has been followed till now. Now what is paged attention means, now while storing this KV cache, what they will do is, before running the model, they will allocate a contiguous memory. So contiguous memory is, the memory will be stored from 1 2 3, I mean contiguous location 1 2 3 4 5 6, I mean the addresses may differ, but I'm just giving it as an example. You might have words of array. Arrays are contiguous memory, linked list or non-contiguous memory. Similar to that, like arrays, we will allocate a contiguous set of memory. Let's say we allocate 20 GB for this KV cache as a contiguous memory. Means after we allocated, we can't use the 20 GB of memory for any purposes. Like the 20 GB of memory is freezed in your system. No one can touch it in except the LLM. So we are blocking a 20 GB of memory even when it's not used fully. Let's say you are let's take this example itself. Who, you are just generating who are you. You can see there is only 3 words, I mean 3 tokens, 1 2 3. Let's say it takes about 3 bytes or 4 bytes of memory. It takes less amount of memory only. So rest 19 more than 19 GB of memory will be wasted. I mean it's just free, sitting still there. You only generated 3 tokens. Let's say, I mean you might not generate 3 tokens. Let's say you're generating only 100 tokens. Let's say about 500 MB of memory only is filled in the KV cache. Rest 19.5 GB is wasted. It's just sitting there, no use for that. So if multiple user wants to use it, means they can't access it because 19 GB is waste. So in order to efficiently use the memory, they introduced vLLM introduced the concept called paged attention. So now what this does is, paged attention, instead of storing the KV cache in a contiguous set of memory, they have splitted it into separate pages, non-contiguous pages. So in a high level point of view, what it does is, instead of holding 20 GB of memory in the beginning itself, what it will do, it will hold only some amount of memory. Let's say memory which is required to hold only 15 tokens. So the CPU will not allocate the entire 20 GB. So first it will hold only this memory required to hold just 15 tokens. Let's say you are asking a question, who are you? So it will answer, I am Hari. So for this, if this I am Hari fits under this 15 token, the rest of the memory will not be allocated. It just uses a 15 token amount of memory. Let's say if it exceeds 15 token, let's say you're asking tell a brief about myself or some other thing like that, or you're just sharing an image and asking it to give a summary of that image, then the number of token is generated will exceed 15. So in that case, what it will do, it will generate it will allocate the memory after the number of token exceeds 15. So each time the number of token exceeds 15, it will allocate the memory at that time, so that no memory is being wasted or it becomes stagnant. So this is the use of paged attention. So by this mechanism, multiple users can use this 20 GB of memory. So this is the paged attention, and this was introduced in vLLM, and it's very powerful, and it main thing it focuses on scalability for more people to use it. So I hope you have understood the paged attentions, or if you want to get more into mathematics or something, you can post it in the comments. I will make a separate video for you guys. Yeah, next one is multi GPU and tensor parallel, and also it has multi GPU support. You can run this model in multiple GPUs, and also you can run the tensors in parallel, so that the inference time and also the time at which the LLM gives us the output becomes very low. And the another one thing, it needs GPU to run well. Unlike Ollama, it's compatible, it's run well in CPU also. This one needs GPU in order to run it well, and also it will be very ideal for running in Cloud Run and Google Kubernetes engine. You can use vLLM in order to host your model in Cloud Run. If you don't have the required hardware, usually you can host it to Cloud Run and also GKE. And as I said, it's best for production high concurrency cloud. Yeah, now let me go to the next part. Okay, so I will tell you now I will explain you about the project which I made using the Gemma 4. A simple project, example project which I made, so that you guys understand how to use this Gemma 4 with Google ADK agent. So simple, we will just give a user prompt plus image, and also this Gemma 4 is multimodal. I have already mentioned it in the previous image which I explained you, but I am saying it again. It's multimodal. Multimodal, it supports image, audio and text. Now, so what I made is, in order to show its multimodal capabilities, I am giving an image as an giving input as an image as an example for you. So user prompt and image, I will share an image plus user prompt, like explain an image or ask a specific question about the image. All those things I will do. I made a agent using Google ADK, and first it will go to the orchestrator agent, and it is a multi-agent setup. So it has two sub agents. One is vision analyzer, and second one is explainer agent. So what this vision analyzer does is, it just analyzes the image. It extracts all the useful information, whatever it's seeing in the image, extracts all those information and gives to the explainer agent. This explainer agent goes through all the understandings of the vision analyzer and generates a user ready response. It gives a user friendly response to us. That's it. And for connecting this Gemma 4 to the ADK agent, we are using LiteLLM. Since Ollama gives us OpenAI endpoints, ADK also has a support to support OpenAI endpoints via LiteLLM bridge. So we are using LiteLLM library to connect the Gemma 4. No API key is needed. Thus, just we can give the localhost link in which we hosted the Gemma 4, and we can easily make the ADK agent with zero cost. It's fully free, zero cost. You just need your laptop. And also this Gemma 4 2 billion model, it easily runs in a 4 GB VRAM. My system has only a 4 GB VRAM. Even if you don't have VRAM, and you can also try to run it in CPU also, but it will be somewhat slow. So if you are okay with it, you can try it out if you want to just see how it works. So now let us go and dive into the code, so that I will explain you how it's working in the code, and we can move to the demo. Okay, now let me go through the agent code for you, so that you may understand what type of agent we are building. So first, in the imports, I am importing the Google ADK required libraries, LLM agent, sequential agent, and also for the model we are using LiteLLM, because we need to import the model which we have hosted in the Ollama. So in this you can see we are giving an OpenAI endpoint, because Ollama is OpenAI compatible, so we are giving the OpenAI endpoint. And this vision analyzer, you can see it in the prompt, you can see it extracts all the visual information from the screenshot, diagram, everything which is present in the image. It simply extracts all those information. And this is a second agent. This is a explainer suggester. So what it does, it explains the image, gives actionable items. So what is the thing which is recommended. So it just simply explains the image, and if you ask any questions to it, it just answers the question. That's the job of this one. Root agent, which acts as a orchestrator. So what it does is simply a sequential agent. First we are doing visual analyzer, and then afterwards we are doing explainer suggester. So it basically runs in a sequence. First it always runs in a sequence. First vision analyzer completes and gives the output to explainer suggester, and explainer suggester runs and gives the output to us. So that's what it happens. This main.py is what actually calls the agent and gives us the demo. So we are using in-memory session service. If you want to know more detail about what is session service, how to create a session service, how to call a agent using session service, all those things I have explained in my previous videos. Also I have made a playlist called ADK Masterclass. You can go through this playlist in order to get more information about how ADK processes the prompt, how to create session, how to handle memory. All those things I have explained clearly with a real world example. So you can go through it or see the video, so that it will be helpful for you. And this is a simple UI. I will show you while running the program. This is a simple UI, so you can go through it actually. So first in the readme I have given step by step how to install Ollama, how to install Gemma 4. Everything I have given step by step. You can follow this step by step in order to test your agent. First we will install Ollama, and then we will pull Gemma 4 from the internet easily, just a single command, and then we will run the Gemma 4 model. And then you need to clone my repo in order to get the code actually, and also go to the code and just create a Python environment. Always it is wise to create a Python environment, so that the library version doesn't conflict with other projects which you are doing in your laptop. And install the libraries, and then you need to add this endpoints in the .env actually. And to run the app, you just need to simply give this command. I will copy this, and then I will run it. Okay, now we can see it's running in this port. Let me quickly go to this. Okay, now let me upload a image. Okay, this is just a architecture diagram of a project which I made, which I was working on. Let me just explain a simple prompt, and let's analyze. Okay, now we got the output from the agent. You can see this visual analyzer agent, the output which it has given. It has just simply given explained us the image, what are all present in the image, all those things it has explained point by point. And after this, input goes to the explainer suggester. So what it does, it just explains and suggests us the changes. So it just explains the image, and it suggests what to improve, or if there is anything we need to add. All those things it will explain, and all those things it was done by Gemma. You can see how nice the output it has given us. It's very good, right? For a 2 billion parameter model, it's very good. It also has function calling, all those things. It's fully based, good for agentic AI. So this is a small demo for you guys. So if you want to try out this project or explore Gemma 4 more, you can easily clone my repo and try it out actually. I have given step by step how to use the Ollama model with Gemma 4, and also how to make an ADK agent out of it. I have given the link to my GitHub Repo in my description, and also don't forget to subscribe for more videos like this. Thank you.